Okay, next we have Melissa Santee.
Hi guys, my name is Melissa Santee, and I work for Mote Marine Laboratory in the OA program under Dr. Emily Hall in Summerlin Key, Florida. Today I will be presenting on the effects of sargassum on Acropora cervircornis under acidification conditions. As continued CO2 emissions are influencing the ocean's carbonate chemistry, there is a considerable amount of research supporting that ocean acidification negatively affects coral and positively affects algae. Ocean acidification leads to a shift in bioavailable carbonate for coral calcification to bicarbonate, which most coral species cannot utilize. In parallel, many non-calcifying algae can utilize and thrive on increased bicarbonate and CO2. With this in mind, sargassum blooms are expected to increase in size and frequency. For the purpose of this study, we will take a closer look at the physiological impacts of the potential interactions highlighted here in red. Ooh, did that double? Yeah. With these interactions in mind, we hypothesize that the presence of sargassum algae exacerbates negative impacts on coral, of OA on coral. Therefore, the project's objective was to examine the physiological responses of A. cervicornis to acidified condition, sargassum, and a combination of both. The experiment was held in CHAOS. CHAOS is the Climate and Acidification Ocean Simulator, which allowed us to selectively manipulate the water chemistry of our treatment tanks, as you can see here in the photo on the left. And the photo on the right is an overhead view of the sargassum treated tank. This diagram is a side view of the same sargassum treated tank. As you can see, the sargassum was kept physically separate from the coral by a mesh net. This barrier ensured that they were not physically interacting, but both were still exposed to the same environmental treatment, whether that be OA water or ambient water, therefore preventing any sort of shading while still allowing chemical interactions to occur. The data that was collected was buoyant weight, surface area using 3D scanning, and PAM fluorometry, were the main three methods used at the beginning, middle, and the end of this 2-month experiment. When compared to the true control, OA significantly reduces the final FV over FM. Conversely, when algae is present, there is a significant increase in final FV over FM in both ambient and OA conditions. The acidified sargassum treatment is the same as the true control condition, suggesting that sargassum may mitigate OA effects with regards to FV over FM. Similarly to the previous slide, the ETR data parallels the FV over FM data, which further reinforces that the idea of sargassum may mitigate physiological effects of OA on A. cervicornis. As we shift to review the physiological parameters, it's important to remember that OA negatively affects A. cervicornis based on many previous studies. The bigger question is, how does the presence of sargassum in combination with acidification affect A. cervicornis? As you can see in this study, the OA condition slightly decreases buoyant weight, though insignificantly. But algae presence significantly reduces buoyant weight, especially in combination with OA. Our original hypothesis was that the presence of sargassum would exacerbate the negative impacts of OA on coral. Based on the data, the three main conclusions can be drawn. We know OA has negative effects on A. cervicornis photosynthetic efficiency and growth. In OA conditions, the presence of sargassum alleviates the effect of photosynthetic efficiency, but exacerbates the effect on growth. And as interesting as this is, it leaves us with some further questions. In order to tease out any of these nuances, I might be a slide. As a result, further investigations are required. As we expect to see an increase in sargassum blooms and other environmental shifts due to climate change, this research becomes increasingly influential, especially as we strive to improve the health of our reefs. We would like to thank the Mote OA intern, to the many sources of funding, and the Florida Keys National Marine Sanctuary permits that allowed this work to be done. Thank you.